Xiomara González Briones. I'm a student at the career of engineering petrochemical process at the Autónoma de Tamaulipas, and I'm going to talk about aromatic hydrocarbons.
Aromatic hydrocarbons, benzene, toluene, xylene. Definition: the aromatic hydrocarbons are cyclic hydrocarbons, so called because the strong aroma that characterizes most of them. Benzene derivatives are considered since the cyclic structure of benzene is present in all aromatic compounds. The structure of benzene is characterized by 1. It is a closed structure with a regular hexagonal shape, but without alternating between simple and double bonds, carbon-carbon. 2. Its 6 carbon atoms are equivalent to each other, since they are monosubstituted derivatives which makes them identical. Toluene is a substance that is also known as a methylbenzene. It is a hydrocarbon of the aromatic type that is produced from benzene. Xylene, xylol, or dimethylbenzene is any one of the three isomers of dimethylbenzene or a combination thereof. Each of the three compounds has a central benzene ring with two methyl groups attached. As substance, there are all colorless, flammable liquids, some of which are of great industrial value. The mixture is referred to as botuline and more precisely xylenes. Obtaining process: separation of aromatic hydrocarbon BTH. Before separating the aromatics, the pyrolysis gasoline from steam cracking to obtain olefins or the crude benzene from cook ovens is subject to hydrogenation to remove the polymer olefins. Reformed gasoline can be proceeded directly for the separation of aromatic. The first step of separation is usually a distillation to separate the fraction in the range of 80 to 145 to be fractionated, taking into account the boiling temperatures of the BTH and eliminating the light and heavy. Due to the formation of isotropic mixtures between some aromatics, naphthenics, and paraffins with the still range, the next step is the separation of the aromatics of non-aromatics with the use of solvent by isotropic distillation, exotropy, or by liquid extraction. In isotropic distillation, the addition of polar solvents such as acetone or methanol increases the volatility of the non-aromatic ones, which comes out as head. The aromatics remain as tails. This technique is economical when the aromatic content is high, 90%, and therefore the amount of non-aromatics can be separated as is low. As for example, in the pyrolysis gasoline or in the crude benzene obtained in the cooking of the coal. In the extractive distillation, a selective solvent of aromatic is used, which decreases the relative volatility of the aromatics, the non-aromatic ones being removed per head and the solvent and aromatic acetyls. It is used mainly when the content of aromatic is ordered to 65 to 90 as in the pyrolysis gasoline, and is one more restricted application, although some solvents allow the joint separation of example benzene and toluene. In the following chart, an extraction with sulfonol is shown followed by recovery of solvent. The aromatics of the feed are extracted into column E, with the solvent that is produced overhead and flows downwards, leaving the non-aromatic refined per head, from which the rest of the solvent is extracted with water in a second column. In the column AD, the non-aromatic ones are separated per head, returning to the extractor as a counter solvent. The bottom of this stripper is a stream of aromatics and a solvent that separates into the next column, RC. The flow diagram of extractive distillation is a simpler since fewer columns are required. The separation of benzene by extractive distillation is shown in the following chart. The feeds per head and feed to the distillation column, in which the solvent is also fed overhead. The known aromatic fraction, containing a minimum amount of benzene, is separated at the head of the column. The mixture of solvent and benzene is separated to another column, at the bottom of which the solvent is recovered, which returns to the extractive distillation. Normally, the extractive distillation is preceded by a distillation to obtain the corresponding fraction of aromatics. Once the known aromatics have been separated, the different components of the aromatic fraction can be separated by distillation: benzene, toluene, or toluene, and if desired, also the AB. Uses and applications. The economic importance of aromatic hydrocarbons has increased progressively since coal-tar naphtha was used as rubber solvent at the beginning of the 19th century. At present, the main uses of aromatic compounds as pure products are the chemical synthesis of plastics, synthetic rubber, paints, pigments, explosives, pesticides, detergents, perfumes, and drugs. They are also used mainly in the form of mixtures, as solvent and as constitutes in varying proportion of gasoline. Benzene has been widely used in the manufacture of styrene, phenols, maleic anhydride, detergents, explosives, pharmaceutical, and dyes. And he is also being used as fuel, chemical reagent, and extraction agent for seed and nuts. Toluene is a solvent for oils, resins, natural, mixed with cyclohexane, and synthetic rubber, coal tar, asphalt, tar, and acetylcellulose, hot mixed with ethanol. It is also used as a solvent and diluent of cellulose paints and varnishes, and as a thinner of rubber inks. Toluene is used as a diluent for paints and varnishes in pharmaceutical products, as a high-octane additive in aircraft fuels, in the synthesis of dyes, and in the production of oxalic acids, because toluene is a good solvent for paraffin. Toluenes, as well as benzene and toluene, are the major components of gasoline and jet fuels. Toluene is used as a solvent and in the synthesis of intermediate compounds. These are widely used for the elaboration of a wide range of chemical products. Petrochemical complex. The Cangrejera Petrochemical Complex, belonging to Petróleos Mexicanos, is located southeast of the city of Coatzacoalcos, Veracruz, which began to produce since 1980 in the second largest complex in Mexico, with installed capacity of 2.8 million metric tons of products per year. It is the largest of its kind in Latin America. Number of plants and capacity. It currently operates with 16 plants, which are directed to a chain of derivatives of ethylene and another aromatics, obtaining as main products the low-density polyethylene, styrene, ethylene oxide, benzene, toluene, among others. For the production of aromatics, the process of catalytic refining of naphtha is used. In 2009, the petrochemical complex reported production of the total production was 3,120,000. The part of benzene was 79,000. The part of toluene was 139,000. And finally, the part of Chilenos was 60,000.